Thank you very much, and good morning. Welcome to AppleFest 88 here in San Francisco. I had a really great summer. I was on sabbatical for almost 2 months, and it gave me time to think and reflect about the world that we live in and the future of our country. You know, in less than 60 days, we have a presidential election. We're going to select a new president of the United States, a leader of the free world. Yet we hear almost nothing about how either candidate is going to lead our country into the 21st century. As perspective, America's greatness in the 20th century has been built on the industrial age model. It's an age where the U.S. has been at the top of an economic pyramid, where we took the natural resources out of the ground, not only in our own country, but also from third world countries. We added our manufacturing know-how to those resources, and this is what has created the economy that has supported our affluent middle-class lifestyle that is so envied by the rest of the world here in the United States. But we are now in the information age. We have made the passage. It's no longer resources out of the ground that are strategic. It is ideas and information. We live in a global, dynamic world where change is the norm, where there is a network of interdependencies between countries, where information moves instantaneously. In fact, all the ground rules are changing from what we have known in the past. You know, we hear catchphrases from our presidential candidates of what they are against, but what are they for? What are they for in the context of America's 21st century needs? We have a changing workforce, changing jobs for Americans in order to be able to compete in this global marketplace. But what are the education needs? What are the job training needs? What are the tools that all of us are going to need to be successful in the information age? And how will our lives and lifestyles be affected as we become part of this global dynamic economy? It is in this context that I think we can best understand Apple Computer back in 1977. Apple was a company that was founded on a vision that had its roots in the homebrew computer club, only miles from where we are today. The roots in a new generation that was perhaps too young for the 1960s, but still had revolutionary ideas. Roots in excitement of how changing society could be done in a positive way, and roots in focusing on empowering individuals and believing that individuals could actually make a difference in the world. A belief that individuals, not institutions, would be the key to the future. Now, this explains why I believe that the Apple II was the perfect product. It pushed technology beyond the limits of what conventional wisdom thought was possible. And it also gave individuals an incredible tool for the mind, pushing individual achievement beyond our natural abilities. It was a tool that ignited a revolution for individuals. It used high technology, and it showed us new ways of doing things. Now imagine yourself in the early days of Apple. The Apple II really was a revolutionary product because it was conceived from the perspective of the people who were going to be using it. It had a keyboard, built-in AppleSoft Basic so you could program it, slots for expansion and modification, manual so you could actually understand it, color, floppy disk drive. It was easier to use than any computer that anyone had ever seen. It was really the Model A of computing. It was the people's computer. Well, Apple II users were and are very special kinds of people. They've always been pioneers because they saw the importance of integrating personal computing into their daily environment. They saw the Apple II as a tool, that getting information and turning information into ideas was really important to them. And the result is that Apple II users have had a love affair with their product, just as the users of the Model A or the Model II or the early Ford tractor had a love affair with their product, or the users of the Volkswagen Beetle, a love affair with their product. We've seen a love affair with the Apple II, the II Plus, and now with the IIc and IIe and Apple II GS. There's such an incredible range of things that you can do with an Apple II. Remember Barney Clark, the courageous man who struggled to stay alive with an artificial heart? He did that with the help of an Apple II, which managed his artificial heart. You know that an Apple IIc has made it all the way to the top of Mount Everest, carried through that perilous climb. Remember the Voyager, the plane that flew nonstop around the world? Dick Rutan, who designed that, did it with the help of an Apple II. And in fact, he uses an Apple II today to support his pen plotter for aeronautical design. And you might be interested to know that when America returns to space with our next shuttle mission, Discovery, there'll be an Apple II GS on board, because they will be testing how the computer system can operate in zero-gravity conditions. The Apple II is truly a remarkable product. It's one that has touched many people's lives. I remember the story of a disabled accountant who took an Apple IIc and a modem, and they were able to continue their business from their home because they had this kind of tool to work with. There are students in the hospital in Galveston, Texas, who would otherwise be isolated from education, except they have Apple IIcs and Apple IIes and Apple II GSs, and this gives them a contact to the outside world. But one of the stories that I enjoy best is an experience that I had just months ago when I was traveling through the Far East on an extended trip. And in every location that I was in, Tokyo, Hong Kong, Singapore, Bangkok, I would be connected by electronic mail to what was going on back at Apple. And I remember when I arrived in Hong Kong, I saw 2 electronic mail messages for me from 2 children at the Lester School in Memphis, Tennessee, one of the Apple classrooms of tomorrow. And they said, "We hear that you're coming to Memphis to give a speech at the university, the medical school there, in Rhodes College. Is there any chance you could come and visit our school?" And I linked them back and I said, "Well, thanks for the invitation, but I just don't know how we can fit it into the schedule." And then I arrived in Tokyo, and this time I had 5 electronic mail messages. And I answered each one of them with the same request. Said, "I just don't know how I can do it." And then I arrived in Singapore, and I had 11 electronic mail messages. Well, by the time I got to about the 8th or 9th message, I said, "I better go see this school. This is a bunch of very persistent young people." I went to the Lester School, school that is in a ghetto area, school that 2 years ago was at the bottom of the heap in terms of test scores, where children grew up without families in the sense that most of us are familiar with, surrounded by drugs, surrounded by poverty, no self-esteem with either the kids or the teachers. Yet the school I walked into was very different than what I had just described. I walked into a school where on the bulletin board, as you entered the school, was the names of parents who had signed up to participate in activities with this school and work with the students. Went up to the classrooms where kids were working with Apple IIs, and they were working with AppleWorks and were writing with it. And these were bright-eyed kids. They were interested in what they were doing. And the teachers had self-esteem. This was a proud school, and anyone who says that there are no solutions to America's education problem doesn't know what they're talking about. They just need to go see what we can do with the tools that we have today. This is what we haven't heard from our presidential candidates. And yet this is a good example of what is happening in the world because of a dream that started back in 1977. A dream to have a positive impact on society. A dream, a handful of young people, some of them still in their teens or early 20s. Well, Apple Computer makes two different families of computers, the Macintosh and the Apple II. They're two different styles of computing that dance well together. Macintosh IIs are used as programming tools for the Apple II GS. We now have joint networking between the Macintosh and the Apple II. And yes, we can even share peripherals between the two families. But they're also very different products. The Macintosh is one of the most advanced professional personal computer systems in the world. But its power is buffered from the user by an incredible user interface. To use an automobile analogy, it's an automatic transmission. You know, I remember when I was a teenager and I was learning how to drive, and I learned how to drive on an old Chevy, stick shift Chevy. It's an experience that I'll never forget. In fact, I wish I still had that car because I felt in touch with the driving experience. And I think that that's a good analogy of what it's like to use an Apple II. It's like a stick shift car. It gives you the ability to shift down when you want to do it. You know you are in connection with the chips, in connection with the technology without buffers. It appeals to people who enjoy knowing how it works. This summer, when I was on sabbatical, I went to a photography school called the Main Photographic Workshop. And I showed up with one of the fanciest, most advanced electronic programmable 35mm cameras that you can imagine. It was only a few days later that I discovered that real photographers, people who are really into it, don't use products like that. They want to be in touch with the technology. And I switched over to a much simpler camera, but one which gave me a far more rewarding experience. The Apple II offers a similar style, only with computing. It's accessible, it's practical, and it's down to earth. In 1980s terms, it's like the hottest selling vehicle around, the pickup truck. Many people don't want a car to drive, which hides the experience. They want to feel the gears working a bit. There's no pink noise. There's no buffer between the users and the chips. See, Apple II loyalists have watched the software continue to enhance the hardware. They appreciate the genius of Woz with his original board design, which was a breakthrough in computer technology. No computer in the world has inspired a greater range of user-driven applications than the Apple II. And there are even more exciting ones that are going to be introduced here at AppleFest. Now, I have a bit of a public confession to make to all of you, but I'd like to give you some perspective first. In 1985, we at Apple were in a crisis of corporate survival. We had to prove that the Macintosh could succeed in business, and it was consuming most of the energy of people at Apple. We had to deliver the Macintosh Plus in 1986 to deliver on some missing promises. The Macintosh SE and the Macintosh II have achieved our original Macintosh vision, and the momentum is very strong. Competitors are in some confusion today with bus wars, with interface wars, and standards wars. But we took our eye off of the Apple II, and we did it intentionally, which shifted the burden of responsibility to a few key Apple champions inside of our company. And it shifted the responsibility to K through 12 education people. And it shifted responsibility to developers and to user groups and to enthusiasts. Well, this was a pretty lonely time for many Apple II lovers. Now, as you may know, my background is marketing, and I know how difficult it is to change people's perception about a company. It was a crucial time for us, and we had to change perceptions that Apple was just a home computer company. Therefore, we focused the Apple II on education, both in the schools and in the home. Even though users and developers continued to use and create applications for the home office, for small business, for home productivity, for entertainment, for music, for publishing. You may remember 4.5 years ago that we introduced the Apple IIc right here in San Francisco. Now, I have to apologize again because I have said publicly this year that Apple would not introduce any new CPUs in this fiscal year. Our fiscal year ends in 14 days. So I was wrong. I underestimated just what our team was able to do. Now, the last time I did this, we had an earthquake, so hold on to your seats. This time, all we have is a level 5 hurricane. But we haven't abandoned the Apple II. In fact, we have done a lot. If you remember, the original Apple IIc was compact. It was a product which gave us a whole new entry point into the Apple II family. And now we've done for the Apple IIc what we did for the Macintosh when we brought out the Macintosh Plus. You know, we have now turned the Apple IIc into an even greater product. And this is the Apple IIc Plus. Now, this may look very familiar to you. It's the same form factor, but there are a lot of changes. In fact, almost everything that you know about the IIc has changed in some way. For starters, it has a built-in 800 KB 3.5-inch disk drive with an auto eject button on the side. It's also got a built-in power supply, which replaces the brick on a leash that so many of us were familiar with. Now, one of the things that always bugged me about the keyboard was that little tiny itty-bitty return key. We've fixed the return key. It's much easier to use. We've also changed the switch up here, which was a 40-80 column switch, and we have an 80 column default built in, so we now have used that space for a volume control on the sound. The back of the computer has the standard ports that will allow the Apple IIc to work with other Apple peripherals, including the mini DIN connectors for both the printer and for the modem. There is space provided inside for third-party modems, and we expect that there will be a third-party flat panel display for the product, which I think is going to make it a pretty neat system overall. In addition to that, we have increased the performance from 1 megahertz to 4 megahertz. It's 4 times faster in performance than the IIc. Now, this is a product that has had a lot of feedback from users. One of the things users were having problem with was the handle, that when they would set the IIc up, the handle would slip out on them. This one doesn't slip anymore. So those little details make a big difference if you're a heavy user of the product. I should mention that we have excellent compatibility between the IIc Plus and the IIc. In fact, of the applications we have checked, which I think is literally hundreds and hundreds of them, we're over 98% compatible between the two systems. And those that weren't compatible, we have talked to the developers to do the fine-tuning to make them so. We have a second product announcement, and that has to do with the Apple II GS. It was just 2 years ago, in fact almost to the day, September 20th, 1986, that we brought the 2GS to the market. This was a product that offered more performance, more functionality, and ease of use. It was a high end of the Apple II product line. It was a great product, but it still had some missing features. It's taken us a long time to get the operating system ready, which would give you the full advantages of what is possible with the Apple IIgs. But we have it now, and it's called GSOS, and I'd like to tell you a little bit about it. First, it's increased disk access, which means that you can boot the system at a much faster rate, and it supports disk-intensive applications, which means it just doesn't take as long anymore. Second of all, it has something called FST, which is File System Translators. Now, this allows you to read data not only from ProDOS 16 files, but also from non-ProDOS files like High Sierra for CD-ROM, something which I believe is going to be very important for the Apple IIgs. And in the future, you will see other operating system file structures that will be supported by FST. In addition, we have RAM-based device drivers. Now, this means that developers can optimize their I/O devices and their applications, which means we can replace the firmware that was in the ROM, and it increases the speed from approximately 1 megahertz to almost 3 megahertz. And it allows for much easier updating of our system software because it's not ROM-based. Here it is, the new GSOS. But that's not all, because it's got Finder 1.2. Now, this provides a desktop environment which takes full advantage of GSOS. It has advanced disk utility, which improves the function of disk tasks, naming, initializing, and erasing. And it has installer to create and update startup disks and customize any disk. Now, both of these products, the Apple IIc Plus and GSOS, are in our distribution centers right now, and they are shipping today. Well, these two major new product announcements are just the beginning. We expect that the IIc Plus is going to get very strong support from third-party developers, both hardware and software. We expect that there will be more enhancements in GSOS in the future. And we are still working on more Apple II CPUs. In fact, we expect to be able to introduce another Apple II CPU between a year and 18 months from now. The Apple II is alive and well. It has a distinct group of core loyalists with a following that is very broad in interests, from small business to entertainment to education to home office to home productivity. And I think that what you will see here at AppleFest will be living proof of just how exciting the future is for the Apple II. Thank you very much.
I know how it is. I know the embarrassment and being alone and scared to say, "Hey, I don't know how to read." That's real scary when it's like somebody being blind and opened their eyes for the first time.
I work at Chemeketa Community College. Now, Chemeketa is a funny name that means place where peaceful rivers meet. Last year, we had over 3,700 students in a literacy program. I was instrumental in championing the use of the computer as a tool and then helping to train other teachers on how they could use it with their students as well, and making the teachers feel comfortable with the use of the computer. Computers need to be easy to use not only for the students but also for the teachers. Santos and Maria Delgado came to us at Chemeketa to improve their English skills and their writing and reading skills. Maria is one of our many success stories, but Maria began at about 4th or 5th grade reading level and has this year graduated with her GED. That's equivalent to a high school diploma.
I didn't know how to spell, and I was so scared of being criticized like I had been all my life, and I was so scared, but they just began to help me how to learn and how to spell, and it just became gradually, and it felt wonderful. Sandy would teach me, and she would say, "I will not hear I can't do it." We don't say that around here. I can do it.
Students may come initially to do something as simple as to read a specific newspaper article or a sports page.
I would just make phone calls because I was afraid to write. I was afraid that they wouldn't understand me.
Maria's interest in computers expanded into writing. She initially wanted to be able to write notes to teachers at school. The fascination with the computer itself sparked this confidence. It expanded beyond that into an interest in writing experiences from her childhood.
I would just make up stories, and I didn't even realize that I knew and that I had shared all that in a printout that came out when I wasn't even able to talk to people before. A special person. This is a true story. One of the special people in my life was a man named Tiburcio Perez. He was like a father to me, but when we moved to Oregon, I missed him so much. I'm so glad I got to be his friend. If people would only take the time to know people for what they are, life would be so much better.
Half the people in here can't even read a simple road sign. Many of them can't read, period.
More than anything, I'm an educator. I'm a technologist as well. But I truly believe that we need to seek alternative ways to provide education.
In the Los Angeles County jails where I work, we started with individualized programs, mainly print-oriented. But we found that we couldn't attract and hold the students we really needed to reach.
About 7 years ago, the director of correctional education decided she would like to put more of an emphasis on the use of technology. I think there is no question that the computer is really an attractive learning device.
Okay, so click B. Correct.
It gives them a feeling that they have control over their learning. Computers are excellent for drill and practice. They're excellent for simulation. No matter what program an inmate is using in the classroom, it is the teacher who introduces them to that program, who moves them through those materials, and the teacher, again, is still the most important ingredient.
I can accommodate twice as many students with computers because they are self-teaching, and I can monitor them. There's less paperwork. The students get immediate feedback.
Workplace literacy, intergenerational literacy. There are a variety of new programs that are now being developed. I truly believe that technology offers a real potential for helping to resolve this real national crisis of adult functional illiteracy. And it is a national crisis.
Alan, he's the oldest. He's 7 years old. He just started school, and he is having trouble. But I want to correct before he starts slipping. They got a computer, and they working with him too, just like what I'm working on. He's really advancing him. If I had it at my time, I probably wouldn't be in the same shape what I'm in right now.
Pete Scarce was the inspiration for my personal interest in the reading program here at Broyhill Furniture.
I grew up enjoying reading from the first grade and going to college, and had a very
different upbringing than Pete educationally. Pete and I had worked together for some time learning how to read a ruler. He had had some difficulty and had not picked up the skills when he was in school. And so here was the first time I had ever dealt with someone who looked at me and said, I cannot read. And I just remember the strongest point in my mind was that when Pete told me he couldn't read, I had to learn how to teach him. Read it back now.
Okay, all the boys and girls ready. We're ready to play baseball.
I think there are two things that have made the program special. One is that we offer the program during the workday, and we do pay the employees to come to class on company time. And by offering the computers, it has been an exciting way for them to learn. It's much more interesting for them. They are able to work at their own pace. Good, you're doing good. You've gotten them all right. Yeah. Working with Pete has made me get a real first-hand story of what it's about and what frustration somebody has and what joy they have when they start learning how to read.
I wished I could go back and change things, and it ain't too late. It ain't too late for anybody to change. I mean, because people might down themselves and say, hey, you know, I won't never learn, but you really have to, you can't be negative about things. You have to be positive. You have to put your foot down and say, go for it.
Once Pete started learning how to read, he realized that there were other doors open for him, other opportunities that he could take or pursue to better himself.
If you know how to read, you can pronounce the words correctly. You know what they mean, and you know what they say, and you can pronounce them. You can say them right. Instead of spaghetti, you can say spaghetti. Let's go catch that granddaddy of a fish, that catfish out there. I want to spend more time with my kids to make sure they don't go through the same thing I went through, because I know how it is. You like this one, the running dog?
Yeah, that's good.
You want me to read it to you? Okay, let's read it. Look, Kate, he can see me read, and each time he sees me read, I'm teaching him a little bit more. I mean, he'd be looking at the words when I'm looking at the words. And you don't never know, he might teach me something, you know. And old man saw the dog, said John.
And John.
Yeah, and John. When you know how to read, you can go places, you can do things. It's going to be a computer tech world out there, and they're going to want high school diplomas, they're going to want college degrees, and they're going to want people who knows how to read. They're going to want me.
Apple's Service Operations Center in Campbell, California, a central facility dedicated to the support of service providers around the world with reliable replacement parts for Apple products.
Our goal, our mission, is to provide those with the highest level of parts availability, cycle time and turnaround time from the account to our site and back.
Jim Briady heads up Apple Computer's Service Operations Group.
We support all of Apple product that's ever been shipped with an Apple label on it.
Apple supports a variety of different types of service providers. You have your K through 12 university education accounts, your VARs, your national accounts, your resellers. Each one of these accounts has to come through Apple, either in Chicago Support Center, Charlotte Support Center, or here in Campbell. To order parts from Apple, you have to be Apple authorized.
We're shipping to 3,500 different locations in the United States. The number of shipments continue to grow. January, for example, we turned out 62,000 shipments out of the site. That was up 50% over January of the year before.
But volume is not how the Service Operations Group measures its success. The measure is fill rate. What percent of orders can be filled and shipped within 24 hours? The goal is to be the best in the industry.
So we set a goal of 99%. We're operating today at 99.5%. And I believe this operation is capable of sustaining that.
A service training center is located within the Service Operations Group facility in Campbell, California. It's one of several training centers in the United States where people learn to service Apple products.
The fact that my technicians are trained by Apple means that they're going to usually be able to complete the repair on the first try.
There's a lot of service techs already out in the field that are doing repair, and the ones that are going to be working on Apple equipment, we want to make them the best service providers we can by teaching them how to repair Apple equipment effectively and with the correct methods. The main goal in there is to give the service providers the tools and knowledge necessary to repair Apple equipment. Things like how to use the diagnostics on all Apple products. They have an opportunity to use and diagnose problems with Apple computers. We also teach them how to correctly fill out the paperwork that accompanies the modules back to Apple, the SRO forms. They also learn correct handling of components and logic boards with regards to electrostatic discharge. They actually get hands-on experience with Apple computers.
Whatever Apple sells, I have 100% in my mind that I know exactly what I'm doing when I get there.
Ron Conover, Senior Technical Support Representative for Businessland and a graduate of Apple's Service Training Center.
If I went to an Apple training and I learned their procedure and I didn't use it for 4 or 5 months, if I went back to the book, I can probably refresh myself within 10 or 15 minutes. Apple provides all the proper tools that you need, all the diagnostic utilities that you would need. And they test every component in there, and they can tell you exactly what your problem is, and within 2 or 3 minutes. It's really incredible.
The new diagnostic procedure is called AppleCat, and I honestly believe it's the best thing since sliced bread. What AppleCat does, it's really our first attempt at building artificial intelligence into our diagnostic. It leads you in a very systematic way through the whole system.
Ron replaces the defective module and leaves the component-level repair to the experts at Apple.
We don't actually do any more testing with the board. We send it back to Apple, and their engineers have the high-tech equipment that can make sure it's working right and every time.
We've got a diagnostic and test procedure that allows us to find out what's wrong with it. We make the appropriate repairs, we test it to make sure it works, and then package it up and have it ready to be shipped out.
Meanwhile, the defective module is sent on to the Campbell Service Center.
There's about 3,000 modules per day are coming in to be repaired.
Cliff Story supervises the receiving operation at Campbell, where returned parts are unpacked, examined, and sorted. The receiving team makes certain the part has been correctly identified on the service repair order, and that it was properly packed for its trip back to Apple, because improper packing may damage the part and void the warranty.
Another thing we really stress to the service providers is filling out the SRO forms correctly and completely. It would really help us if you could put the confirmation code, the repair code that you got on the diagnostics, or actually give more information.
From the time they are received, great care is taken to protect the parts from damage by electrostatic discharge.
ESD damage is very subtle. Very often it doesn't cause a failure until long after it's occurred. We carry things around in conductive totes, so it won't build up a static charge. All of our operators wear wrist straps. All of our benches have ground mats. So we go to great lengths to ensure that the product does not receive any ESD damage here.
Each part gets a thorough cleaning and a visual check for physical damage, corrosion, and the like that may make the part irreparable.
We understand what revisions that product went through and what is the latest rev level for that product. If that board is upgradable to the latest rev, we will upgrade it. Then we bring it through our repair process.
We have a scheduling system and people anticipate what we're going to need, and we build to that anticipation. One of our great skills is being able to cope with the unanticipated, our flexibility in order to meet our customers' demand. We have a device called a GenRad, which is an in-circuit tester. It can measure resistors and capacitors, and it can toggle some of the gates and ICs to see that they're functioning.
Many of the center's technicians have years of experience in manufacturing the very products they now service.
I've accused some of these people of being able to do faith healing on these boards. I mean, they put their hands on the boards and they suddenly begin to work again. They know right where to go. They know how to fix them and how to ensure that level of quality that we really want.
Others specialize in the art of reworking.
And what we have are specialists who have solder pots and solder reflow machines, and they know how to operate them, they know how to get the best quality out of them, and they have that kind of specialization so they can rework the boards for the highest quality. Yeah, they're artists at what they do. Surface mount device is a whole new wave of technology. We've had to go and make a fairly substantial investment in surface mount rework equipment.
Any of these specialists can reject a part on their own as not meeting Apple's demanding criteria for parts that are as good as or better than new. Once they are satisfied with their work, the part moves on.
It goes off to a functional test where we actually simulate the real operating environment of the thing. We plug a disk drive in, we plug a keyboard and power supply in, and we actually exercise it to make sure that it's performing to criteria. From there, it'll go to a quality station where it will be measured as part of our sampling plan.
Okay, a tote comes to us, and we'll look at about 1 out of every 5. So we'll plug it in as if we're plugging it into a customer's Mac, and we'll turn on some diagnostic software, and it's specific to each product. If it fails, we call the production supervisor and the process engineer out to verify that, yes, it is a failed board versus our test equipment. Our goal for the repair center is to be equal to or better than manufacturing. We make sure that that board functions and looks exactly like a brand new board. That is our goal.
Service. There's a lot more to it than meets the eye. It is a product in itself whose attributes of speed, accuracy, and economy are highly valued in the marketplace. The remarkable, measurable success of Apple's Service Operations Group has not come easily. It is the result of a company-wide commitment, of major and continuing investments in hardware, systems, and people, a carefully considered and constantly refined strategy, attention to the minutest of details, and an unrelenting focus on the customer.
What we really wanted to do was put Apple and the service organization on the top of the charts when it came to service providers in the United States. We've put in place in Campbell not only the repair operation, but we've put into it the engineering resources in both test and process engineering to be able to support the repair of that product with a very high degree of quality. We're very proud of Campbell. We're proud of the people that work here because they all understand what we mean when we target customer service and customer satisfaction, and we're out delivering that.
Pencil test fits our strategy very well because we're trying to determine what we think our future customers are going to expect from Apple's future machines. We could do a lot of guessing, but instead of that, what we've done is to learn a lot about animation and actually go through the process ourselves of creating an animation. So we really know what it's really like to create one, what all the problems really are.
In the traditional animation as well as computer animation, a pencil test refers to the first rough animation that you get, the wireframe test, or in traditional animation it's pencil drawings.
The key to putting together an animation is to first build your characters in modeling phase, then animate your characters, build your scenes, put in your lights, do all that, which is considered the animation phase, and then rendering, actually applying the color, the material, and the textures to things. Everybody picked a character, they'd come into my office and check out a character. They'd check out a mug or check out a notebook and go on back to their office and work on it, and then Nancy and I would sit down with them and go over, well, this object isn't cartoony enough.
You had to tell them, you've got to exaggerate. But then it doesn't look real, they'd tell me. And it was really hard sometimes to say, I know that's what we're looking for. We're looking for a cartoon here. We're trying to make this cartoonized and style it in a very exaggerated way.
Ken put fangs, the little points on the stapler, really like these fangs that are sitting there, because that was sort of a way he could bring life into the stapler.
The entire film would have taken something like 96 days to compute just on one Macintosh.
We didn't get one Macintosh to do colors, textures, and lighting. We got 30 Macintoshes to do it. Basically, we had a network of Macs sitting in a lab. They were just stacked up to the ceiling.
By having a network of Macintoshes, all computing in parallel, producing one image every 30 seconds or so, we were able to get that kind of turnaround we needed.
The music, sound effects, everything was done entirely on the Mac.
What it's done is taught us what has to be improved in all aspects of the system to make it so that creating animations is as easy as creating desktop publications or desktop presentations.
The group, especially the core group of about 12 people, were there day in and day out working on software, working on textures, working on the animation, and they were so dedicated, and they were there because they wanted to be there.
And this provided a unifying sort of theme for us. All those different aspects of the company, the different aspects of ATG came together for this film. And we became one family for half a year.
Send me off to Hollywood. Bye-bye.
I feel this firm is a real forward-thinking firm. There's some really incredible people working here in this company at Kaufman. And I think there's a lot of creativity in the firm. People are not afraid to try new things here. And I think the Macintosh fits in real nicely with that. It helps us be more creative. It is a new thing, but it's on the leading edge of technology, and that's where we are as a firm.
Kaufman Engineering is a great example of how the Macintosh fits in the technical markets from the standpoint of they do everything.
We do civil, structural, mechanical, and electrical engineering. I think that the Macintosh affects productivity at every level within our operation, from word processing to accounting to project management to engineering to drafting and even to proposal writing and business development. It gives you an opportunity to do more for a lot less.
The Macintosh can do it all, and it does it with very little understanding of programming or anything like that. You can just sit down for the first time and within a few minutes run a spreadsheet or run a word processor.
With the Mac Plus, I was able to use that one day, not use my computer for maybe a month, come back and be right up to speed and continue to use it. Therefore, I used it more. As I bought a Mac Plus, I took it home, I worked with it, I tried out several programs, and I came back and I said, it's here, we're buying them. And we made a corporate commitment. We have discontinued and phasing out of our $1 million computer system, which is now not worth anything. And we're phasing totally into the Mac system.
The Macintosh gives me the freedom to explore different alternatives. When we had done projects in the past using manual drafting, it's a lot more difficult to change things around to explore the different alternatives. Whereas with the Macintosh and the CAD program that we have, it's just a matter of clicking your mouse button and moving a piece of ductwork or a piece of pipe here and there around the drawing. And so you're able to look at all sorts of different options in probably less time than it would take to originally hand draw just the first design, that concept that you'd come up with.
In the old days, we used to have a system where the guy would basically redo stuff over and over again because he could not get at the system.
We were driven by the large system. We had to schedule our staff and people around 3 or 4 workstations, and we found we weren't doing engineering. We're busy trying to manage that system.
Now with the Macintosh, if we have somebody else does a drawing, the engineer with a Mac 2 in his desk can bring up the drawing on his own desk, make changes to it, plot it out himself, and do everything by himself. The Macintosh, in my opinion, is probably the most powerful workstation out there today. You're not limited to one application like most computers are. If you buy like an Apollo or Sun system, basically you bought a CAD package. If you buy a Wang or a Xerox, you basically bought a word processing package. With the Macintosh, you basically bought everything.
I come from an IBM background, and I was really reluctant at first. I thought the Macintosh was a toy. But after being on it for a couple of weeks, I began to see how wrong that view of the Macintosh was. It has probably become, not probably, I would say it has become my #1 design tool in this office. I just would not want to go back to the way things were before.
The Macintosh technology, the Mac 2 specifically, it's going to revolutionize a lot of ways that engineering is being done today. The Mac 2 is a serious piece of equipment. We find that the Mac 2 with the photo expansion capabilities approaches the capability of our central VAX system. And that's not a game. That's real business and real impact and power.
I'm the guy that you may have seen in that ad, and I got to tell you, since doing the ad, I've gotten my share of calls, but I've still managed to keep my job. Since installing Macintoshes here at GTE's headquarters, we found that besides the hardware in that box with the Mac, you get HyperCard. HyperCard is a product that was very interesting to us, so interesting that we've used it to develop an executive information system that we use to provide financial and management data to our executive management here at the headquarters. The EIS gives us access into our financial highlights, into early warnings that we call flash reports, outlook comparisons, which are longer range forecasts, statistical highlights, and a statistical outlook. The financial highlight screen here for our consolidated telephone operations organizations is for the month of June. It shows revenues, expenses, net income, plant additions. The information is updated periodically, and the user gets to set the frequency of that update by linking into the mainframe. With HyperCard, we're able to create linkages from report to report that allow us to look at a piece of data and move very quickly to the same data for a different business unit. Just one jump to the other, and again allows a lot more intuitive comparison than the up and down through the hierarchy of menus on other EIS systems that we had seen. We've had, in the occasion of teaching an executive how to use the system, we've had the experience of having him start to look at real data and start to compare company financials during the first 15 minutes while we're talking to him, all on his own, and being able to make some real decisions within that point of time. To put a new application launch onto the menu is maybe about a 2-minute task for anybody who has learned anything about HyperTalk. It's an extremely easy task to do, yet to the user appears to be something that you spent weeks programming. Not only did we develop our HyperCard EIS system for under $10,000, but that system actually has more feature to it and more flexibility to it than commercially available EIS systems that we've looked at that cost as much as $250,000. In the instance of Mr. Broadhead, an executive, I get concerned that he's spending as much time with it at home as he is that his wife is going to come looking for me. We're working on developing this EIS, the kernel that we've built here, into what we hope will be one of the most sophisticated management reporting systems in the industry.
The Louvre Disc offers an opportunity for students, teachers, people at home to see the Louvre, to see it in the most interactive way. They can look at paintings, they can compare paintings, they can see details from paintings that they might not be able to put together if they were in the Louvre. It's just another way of being there. This disc allows you to be a traveler, a time traveler into the Louvre, to see the paintings in that collection, to study about them in a variety of ways, to compare them, one artist's work, one style of work, a different theme of work, a different period in time.
C'est que cette figure au mystère légendaire n'est plus un simple portrait, mais plutôt le miroir où se reflètent le génie et les rêves de l'artiste.
What interests me in teaching is not so much just a single item, but all the contextual relationships, and the idea that I can take them in other eras and show comparative things, or I can take it to other thematic works by other artists and compare them, that I can get to the Louvre, which I would not typically get to in a working day. HyperCard allows us to do the two kinds of things that we need most to do, which is to search for information and then to communicate what we've searched about, and in this way house that information in a meaningful way, to link it so that we can recombine it and use it in other ways, and to be fluid and creative with information. We're a communication society, yes indeed.
of sailing is in speed, and the faster a boat is in general, the better it is. So we work hard to make them faster. We also want the boats to meet the needs of the sea. They need to be seaworthy, they need to be strong, they need to be beautiful.
I think there's several people around that could probably design a boat as well as the next person if given them enough time and observing all the other boats that are around to see what's fast and what's not. But an America's Cup event, you've got less than 3 years to design a boat and have it tested and have it proven right or wrong, and also make a lot of the changes. If you change one small thing, if you change the waterline length 1/4 of an inch, then you also have to change the sail area, the ballast, the beam of the boat, and so on and so on. So we have to be able to do that very quickly. And without the aid of the computers and whatnot, you're lost. Don't even try.
The Mac is the system of choice because of its ease of use, its graphical interface, the software available to it, and the connectivity of that software, the fact that it is relatively easy to pass data between programs. That's very necessary in our environment and in most environments.
When we originally started developing the software, we were looking for a hardware platform which would provide large amounts of memory, excellent graphics interaction, and ease of use. And when we looked around in the market, the only product which really answered that was the Macintosh.
Ease of use of the Macintosh interface is what truly makes it a productivity tool. The graphical orientation of that interface is very important too, especially in our applications. And we see time and time again that people who have bought IBM or similar products are moving to the Macintosh just because they are simpler to use.
You can look at the Macintosh graphical user interface on 2 levels. It's an easy system to learn, but once you've learnt it, it's also an easy system to use. To make a change to a model, all you have to do is point with the mouse and drag it. That gives you a very easy way to interact. You don't have to type in a command. So you've got an ease of use combined with a lot of power in the system. So it means it's not just a trivial visual interface. There's actually a lot of depth to it.
You want it to be easy to use, because if you have to spend your time thinking about how to run the program, how to physically manipulate the program, make the input, then you're losing sight of the problem that you wish to solve. And so the computer needs to be removed as an obstacle.
The Macintosh is head and shoulders above anything else in terms of the type of end product we can produce. The Mac 2 in particular has so much power. The naval architect can work much more quickly with a mathematical model than he can with a conventional model on the drawing board.
The CAD packages and Mixurf are so sophisticated and so streamlined that it's now possible for me to do a lot more of the work hands-on. So essentially the customer is getting quite a bit bigger bang for his dollar than he did before. He's getting more of my time, he's getting more design iterations because of the productivity and the ease of use of the Macintosh. It truly was remarkable that the America's Cup work with which we were involved was at the leading edge of technology. It was truly the cutting edge. And the argument that the Macintosh is too simple is just wrong. What is simple is what is good. What works is what is good.
So it's a case of making people look forward rather than looking back. And you've got to say, if you want to be competitive in the future, if you want to produce the best solutions, then you're going to have to go with the best way of doing it. And if that means discarding knowledge that you've acquired which is no longer relevant, then that's a price you're going to have to pay. It's not always easy to convince people of that, but the tide's turning.
That is the future that NCSA is headed towards in terms of its Macintosh development. NCSA stands for the National Center for Supercomputing Applications. We're at the University of Illinois at Urbana-Champaign. We're set up to provide supercomputer power to researchers across the country, specifically National Science Foundation researchers. We have about 50 Macintosh 2s in the building. All of them are connected directly to Ethernet. computational scientists spend their time doing computation on computers. They also spend their time writing research articles, doing view graphs, doing communications. The Macintosh 2 fits very well into that environment. It has the wonderful productivity tools. It has the connectivity with our NCSA Telnet using an EtherTalk card, and with our product NCSA Image tool, we can now do visualization of your scientific simulation. This is a simulation of a supersonic jet flow. What we can do here is change the correspondence of colors to numbers. This is a simulation. There's numbers that correspond to the various pressures. We can change what color corresponds to what number, and that correspondence is set by this palette here. The one fun thing to do is what's called fiddle, where we can compress the palette, move the palette left and right, and this will bring up different features. Some of the shock waves here, and some of the internal shock waves that you see there. We wouldn't be here today if it wasn't for the Macintosh. The Macintosh allows us to do supercomputer simulations, both 1D and 2D. Let's take, for example, a 1D simulation. You're producing line graphs. NCSA Telnet has a Tektronix simulator built in. That shows up on the screen. You can cut and paste that directly into your word processing document. You can have your supercomputer or your mainframe generate a series of numbers. You can cut and paste those numbers, paste them into CookieGraph, produce a graph that way. What attracted us to the Macintosh initially was its productivity tools. The fact that you could produce high-quality word processing documents. You couldn't with any other machine. Then the fact that you could integrate text and graphics easily. Okay, we were attracted to the Mac 2 because it's more powerful. You can run multi-finder. You can do the two-dimensional scientific visualization, and you can put the EtherTalk card in, so you can get the high-speed connectivity. You can transfer files. We can transfer files at 40 kilobytes a second over a lightly loaded network. Okay, and that's amazing for a low-priced machine. This is the first time where computational scientists have this capability of being in an integrated environment where their word processing, their connectivity, and their computation can all happen on the same machine.
NASA Ames Research Center is one of 8 field installations of the National Aeronautical and Space Administration. Our mission is to sustain NASA's excellence in aeronautical and space disciplines. Right now, we're using about 300 Mac 2s for all of this scientific research and aeronautical research that we do here at the center. And so the systems are used in CAD/CAM, in MIS, in data acquisition, in graphics, graphic presentations, a number of those areas. And then general purpose use of the system as a desktop office system, of course, supports all the research in these projects that go on. The ease of use is very important, but also the ability to expand the system and integrate it with all the other systems that we have here is very important. The Macs are used to complement the Cray and the supercomputers here at the center for pre- and post-processing, but they're so easily integrated to any system, whether they're emulating a terminal or whether they're doing file transfer between the Mac and a mainframe. I don't know of any case where we can't access another system with the Mac 2. Most of everything we do ultimately results in some kind of a graphical presentation. In the Life Science Project Office, for example, we're running an experiment where we've taken HyperCard and put that to use controlling a robot. That robot ultimately would go on a space station and result in some of the first research that we do in putting people out there. You're able to do a lot of things with the Macintosh that make it a system that's very affordable and attractive here at NASA. We can think a lot faster than we did before because we can take the information that we had, whether it's scientific information or administrative information, and we can draw conclusions from that. You can program and you can do some data analysis here. You can go back and do a word processor. You can bring the whole thing into an end product and then print it out in your laser printer and go in about 15 minutes, and it's wonderful. So you can be a project manager, you can be a scientist, plus you can pull your project together all in one system. Productivity is high when we use the Mac too. And, you know, we're funded by the taxpayers, and they're paying us to do aeronautical research and not to spend a lot of time training and learning how to use a computer. And people love it because they can get to work on it and learn how to use it very quickly and then do the work they're supposed to be doing.